All right. Let me get it set up and we'll start this one. Wait for it. There we go. All right, Rebecca. Oh, it cut that one off for some reason too. I don't know why it's doing that. This one looks like it should say meters. How long does it take to hit the ground? How far? Okay. All right, Rebecca, will you pick somebody to read?
Justin.
An egg is thrown horizontally off the roof, which is 60 meters high with an initial velocity of 6.5 meters per second. How long does it take to hit the ground? How far does it go in the X direction?
All right. It's got a couple things it's asking us for. It's got a couple things that it told us. Let's go ahead and make our picture out of the situation. And actually, this time I'm going to go ahead and put the equations down first. We're going to use the same two equations for all the problems today. And it will help you, if you know the equations, it'll help you to know what to put on the picture. Dresden, you still with me too? The light on your face is also changing frequently.
That's weird because I have a light built into the computer that just shines at me when the camera's on.
Okay. It's mostly from like a different angle, not so much down below, but up higher that
Okay.
the light's changing.
No, that's weird.
For those of you that had me as freshmen, did I ever teach you one of the lectures on cheating, by the way? I feel like I haven't given that lecture for a while. Years ago, I used to give a lecture on how to cheat. And then I would make the point of, this is how I know what to look for. All right. We're going to start labeling stuff. All of these letters on my equation have to show up on the picture before I'm allowed to put them put the numbers into the equations, before I'm allowed to play with the equations. And I don't care if it's a known or an unknown. I'm just going to call out random people and have you tell me something that should go into my picture. So Keone, would you give me something that can go on my picture and tell me if we know it or don't know it? We'll go through that conversation.
An egg.
Well, I already got the egg.
Okay.
It even kind of looks like an egg for once. The tiger looked more like an egg the last time.
I think you should see that little line that it's on. I think you put 60 because that's how high it is for when it gets thrown.
All right, and so with that, you want the 60 to be up here. That sounds good to me. And because that's where I'm starting, that's what I'm going to call the initial height. And while we're at it, where will the final height go?
All right.
Uh-huh.
I'm not here. On the ground?
Uh-huh, yep. Because it's going to fall and hit the ground down here. Somewhere where it will have a final height. And just tell me what makes sense to you. What would be the number for that final height?
0.
0. So there's certain things they will not tell you in the problem, and you're going to be expected to find it on your own.
Yeah.
All right, Alton. Actually, let's go ahead here quickly. So this one was 0, so I'm going to cross it out. This one I know. It's just going to help me keep track of what I've got on my picture. Alton, will you give me something else that should go on my picture?
Distance in the X direction
Uh-huh.
is unknown.
So it's going to come down here, and not only is it unknown, it's how far does it go, It's really unknown. I'm going to put a box around it because it's one of the things I'm looking for. And again, since you gave me a final direction, let's talk about the initial x direction. Where would my initial x direction go?
At the very far left.
Very far left. And you can put it up by the egg. I'm going to bring it down here. It doesn't honestly matter. What would be the number attached to that?
0.
0 meters again. Just makes sense when we start a race, when we start counting, we start from the starting block, we start at 0. So, just to keep tabs, I don't know that. I have something that goes away, so I get to cross it out. Molly, give me something else that goes on my picture.
Do we have to write down the thing for gravity?
Uh-huh. And so when I write down the thing for gravity, I'm talking especially about g, which is an acceleration, but is it the acceleration in the x direction or the y direction?
The Y?
Uh-huh. And conveniently we can assume we're on Earth as we throw this egg. What number is going to be associated with that? Our favorite number of the year.
I don't know.
Phone a friend. It's got a decimal in it.
Is it the 6.5?
It's not the 6.5. That's a good guess. It's a number that doesn't show up in the problem, but we're going to use it all year long. We've used it many, many times before. Like I said,
I don't know.
you can phone a friend. Call on somebody who's in the class.
Dresden.
Is it 9.8 for gravity?
9.8. The big question, though, is it a positive 9.8 or a negative 9.8?
It is positive, right?
It is. How do you know that?
Because you told us.
I didn't tell you yet. Actually, it's not positive anyway. Ha! You're wrong. If you look at your y values here and make a number line out of those, my y final was 0, my y initial was 60. Going from 0 to 60, which direction's positive, up or down?
Up.
So I know that this is going to be my positive direction. Where does gravity always pull me? Doesn't have to be Dresden.
Down.
Gravity always pulls me down. When they fight each other, how do I have to take care of that mathematically? Positive or negative? When your directions fight each other, does that call for a positive or a negative?
A negative.
Calls for a negative. So this will be negative 9.8. Because gravity is fighting our positive direction. And while we're at it, I will go ahead and put this x direction in there as well. Alright, so I've got that. Aaron, would you give me another something that goes on my picture?
The time? Are we looking for the time?
Yep, when it says how long does it take, that is asking for a time. So it means I'm even going to put a box around it. And I've got a whole bunch of times that are listed. I'm going to put a question mark over all of them. Alright, Trey, give me another something that goes on my picture.
How did the AX split equal 0?
Uh-huh. Just like last time, and just like every problem we do this year, AX will equal 0. Which I love, because then it gives me something else to cross out. Kira, give me another one.
Wait. Time?
Time we have on the picture already. Looks like we only have 2 things left to go on the picture from our equations. What has no question mark, check mark, or 0 over it?
Initial velocity.
Which one?
Both of them.
Both of them.
Yeah.
So that I'm going to put them both up here, VIX and VIY. Let's start with VIX. How am I moving horizontally when I jump off the cliff? Or in this case, throw the egg off the cliff? Or more appropriately, how's the egg moving horizontally? How fast?
6.5 meters per second.
Uh-huh. And if I am moving horizontally when I move off the cliff, or rather the egg, what is my vertical component? Same as last problem. Annabelle told me. Krista looks like she was going to go for it.
Is it 0?
It is 0. Because if I'm moving horizontally, I don't leave anything for the vertical. If I throw something horizontally, I didn't throw it vertically. There's no vertical part there. Which means, on one hand, I know this. And on the other hand, I got something else I can cross out. That is the longest part of the problem. That's the part you're going to struggle with. But once you have everything from your equations on your picture, it's not so bad. In fact, it looks a lot like the problem I just solved. And just like the problem I just solved, I would solve for t using the second equation first, then take that t and plug it into the first equation, and use it to solve for xf. And we need both of them. So I'll give you guys a head start. I'll write down what the math will look like in a moment. And I do not believe any answers until I hear it at least 3 times.
So for T, I got 3.499, and then for XF, I got 22.7435.
Okay, so that's what we've got so far. I don't believe any answers till I hear them at least 3 times.
I also got
Yeah.
22.74 and the 3.499.
I got it. Yeah, I got those answers as well.
Okay, that's 3 people. If you don't have them yet, make sure you get the same answer as well, because you do want to check your own math skills. And I don't have these answers in front of me, by the way. I'm going off of what you say. Occasionally, we do have cases where somebody gets a different answer and they're right and everybody else is wrong. But I said that I would go through and show you the mathy parts. Let me go ahead and get that ready now. Go ahead and take the square root, because I'm running out of room. All right. We're almost done. You actually missed something, though. Granted, I missed it too, because I wanted to come back to it.
Units?
Our units. What would be the unit for XF?
That would be meters.
And what would be the unit for time?
Seconds?
Uh-huh.
Oof.
By the way, these problems that I'm having you do are exactly like that lab that I wish we could do. It's my favorite one of the year, but it's one of them I just cannot do virtually. So for Krista, the one I keep telling the class about, my favorite lab that we do all year, I give you a ramp, I give you a marble, and I have you start the marble from the same place so that you can measure your initial velocity as it falls off the table. But you have to catch it before it actually falls. You're just using that just to find the initial velocity. And then I have you find the height of the table. And using just those two pieces of information, you have to predict where the marble will land. And I call it a shoot for your grade lab because I have a bullseye in the classroom that you have to calculate where XF is. And then we go and we put the bullseye right there. Then I let you run it and let it actually hit the ground. And wherever the marble lands, that's your grade on the lab. But we can't do that one this year. That's the saddest moment to me of the whole virtual experience. Is that's my favorite thing of the whole year to do in this class. Because everybody is like, oh no, everybody's freaking out about putting the bullseye down. And then it's not that bad. Unless you get your math wrong. Then we have to redo it.